So we're going to talk about some study skills, and I call this hacking your brain. So our objective here with this lesson is to show you how the brain uses new information to form long-term memories to help you remember things better and learn them permanently rather than just memorizing things for a test, for example. And we're going to talk about some of the best practices for study habits. So we're going to briefly talk about the science of learning. The brain physically changes as the result of experience. So as we have a variety of experiences in our life, the brain actually stores different sensory material, different sensory experiences around our brain in different places. And then there are connections made, both chemical and physical connections, to those different parts of the brain, to those experiences, so that we will remember them. It's important to remember that some kinds of learning takes longer to process and to change the brain. Learning is rewiring. There's certain memories, there's certain things in the brain that are processed by chemicals, and there's certain things where there are actually physical nerve endings and physical nerves that actually connect. And so that we're going to talk about some of that briefly. Thinking and learning are different. So as we look at the difference between thinking and learning, thinking is the transmission of information by chemical messengers. So, and this occurs as if we're just sitting down thinking about something, regardless of what that is. If we're thinking about mowing our yard, for example, those thoughts are being processed by chemical messengers. When we're actually learning, cells will fire together and build stronger connections as we learn. So it's important to remember that, and that does take time to build those stronger connections. Your brain is designed to learn. We have three types of memory. We have sensory memory, working memory, and long-term memory. So as we look at a picture of the brain here, we see that our various senses that we have are located in different parts of our brain. And like I said earlier, the brain connects these various senses by chemicals and physical wiring to be able for us to remember, for example, how to problem solve, how to remember something that someone said to us, remember how something feels through the sense of touch, for example. So as we look at this, we see that speech and problem solving are located in the frontal cortex of the brain. So it's the front part of the brain. It's the red section in this diagram. As we move back across the top of the brain and toward the back, we see in the purple that the sense of touch is located there, and our body orientation. For example, if you close your eyes and stick your arm out, you probably don't have to really think about where your arm is at. You just know it. And that's the part of the brain that deals with that body orientation, and that's actually called proprioception. Our sight is controlled in the back part of the brain called the occipital area, which we're showing here in green. The yellow is hearing and memory, which makes sense from the hearing aspect, because the yellow, it's on the temporal side, which is where the ear enters the brain. Excuse me. Under the bottom of the brain, the darker brown area is called the cerebellum, and that's responsible for our balance and our coordination. And then we have the brain stem, which comes down from the center of the brain and actually sticks down below, in this diagram, comes down the center, sticks down below the cerebellum, is responsible for our breathing and our heart rate. So all of these various senses work together in creating memories. So our initial intake of information is through our sensory memory. And as we see with the pictures here, we have the sense of hearing, the sense of sight, the sense of taste, the sense of smell, and the sense of touch. In EMS, we don't do much with our sense of taste, but the other four senses we use a lot. One thing to remember is sensory memory is very short-lived, seconds to minutes usually. Our working memory is limited to generally 5 to 7 items. And then those items, as we input more information, those items must either be stored in long-term memory, which we'll talk about next, or they get flushed out of the brain because we're not using them. So if we look at our working memory is a place for some temporary storage. It manipulates, it's where we manipulate information through visual and auditory channels. It's where we focus our attention, typically. It affects our school performance and our IQ, and it strengthens through exercise. Now, when I talk about exercise with brain-based learning, I'm not talking about like you might think of exercise like walking or running or lifting weights or something like that. I'm talking about exercising those memories and exercising your brain. The working memory is limited to 5 to 7 items, lasts seconds to hours, so it's a little bit longer than the sensory memory, but it is very sensitive to disruption. So any distractions that take place can disrupt these memories. Your long-term memory is where we want your learning to eventually get to. Your long-term memory will last days to weeks, but the good part about long-term memory is that it's insensitive to disruption. So once you've learned something, you typically do not have to relearn it unless you don't use it for an extremely long period of time. But it's insensitive to disruption, so a variety of distractions, such as noises or people screaming, for example, will not typically disrupt these long-term memories. Again, exercise or experience is critical to learning. So when we refer to exercise with brain-based learning, we're referring to using the information that we've input. Just inputting information doesn't help us learn. That's the first step, but continually inputting information without using it does us no good. So we have to constantly exercise or use that information, and that is very critical to learning. This exercise can be maybe doing skills, doing quizzing, testing, using flashcards, or something like that. Anything where we're actually using the information and you're making your brain retrieve that information. It's often called retrieval practice. Retrieval practice is very important to actual long-term memory learning. New information does take longer. So if you are learning something totally new that you have never thought about, never learned before, it's going to take longer. So it's going to have to go through that process of going into your sensory memory, going into your working memory, and then going into your long-term memory. And that process needs that exercise or that using of that new information in order to really stay in that long-term memory. This is an interesting quote from Jack Canfield. Jack Canfield was an author and psychologist, and it really goes to motivation. And it says, part of paying the price is the willingness to do whatever it takes to get the job done. It comes from a declaration that you are going to get it done no matter what it takes, no matter how long it takes, no matter what comes up. And I think this is important going toward motivation for learning. Learning the way that I'm trying to teach you here is time consuming. And we know that anything that is learned and is put into our long-term memory is going to take a lot of time. So it's very important that you understand that, and there's no quick fixes for this. Okay, so we're going to talk a little bit about emotions and stress. and how and the effects of emotion on learning. Um, Emotions can affect thinking, attention, memory, and therefore learning. And this diagram shows some structures in the middle of the brain, in the center of the brain, that affect different things with our emotion and our stress levels. So the effects of emotions and stress can either be positive or negative. We can have anxiety, stress, or fear, which we would usually see as being negative. Or we can have gratitude, compassion, and joy, which we would generally see as being positive. But any negative emotion has a negative effect on learning. And on the flip side of that, any positive emotion has a positive effect on learning. The amygdala, which you can see in this diagram, is a little bulb-shaped structure in the center of the brain. Is highly associated with our emotions. The amygdala receives input from the senses, processes emotions, and it's very active in storing memories. So as these positive and negative emotions um, work in our brain, the amygdala works to take those emotions and to help the brain learn where those emotions are coming from and what's causing those emotions. So again, if it's a negative emotion, you will remember that negative emotion. And if it's positive, you'll remember that positive emotion. The hippocampus, which is very close to the amygdala, is associated with memory. The hippocampus is greatly affected by stress and can even shrink under prolonged stress. And we know that from learning, from brain-based learning research, that short-term stress can actually help learning. Short-term positive stress. So you're really trying to work at learning something. Maybe you're a little bit nervous, but you're working through the problem-solving portion of learning whatever it is you're trying to learn. But under prolonged stress, the hippocampus can actually shrink, and we know that prolonged stress is not good for our body. The frontal lobe, or in this diagram, it's labeled the prefrontal cortex, is very important to emotional control and reasoning. The frontal lobe is where we think, as we're thinking about things and reasoning through different things. And from our context in the EMT class, if we are trying to figure out the difference, if somebody's having difficulty breathing, for example, and we're trying to figure out the difference between um, asthma and COPD, for example. This is where a lot of this comes from. As long as we've learned that material, the prefrontal cortex helps us go through that reasoning to help us determine that. And the prefrontal cortex, or the frontal lobe, also has a great deal of control on our emotional control as well. When we get angry, for example, very quickly, for people who do that, that is coming from the frontal lobe or the prefrontal cortex. So as we look at the physiology of anxiety and stress, this is a cyclical process. So as we have stress, I'm thinking more of like prolonged stress or negative stress, that can lead to poor performance, depending on how much stress there is and how long you're under that stress. But oftentimes it leads to poor performance. That poor performance creates more stress because you're usually worried about it and trying to work through it and that sort of thing. And that additional stress will lead to additional poor performance, which then leads to additional stress. So it's a cyclical process. So we need to do things to try to break out of this cyclical process. Stress causes the sympathetic nervous system to activate. And when we get into our anatomy and physiology, we'll talk a lot about the sympathetic nervous system. The sympathetic nervous system is that fight or flight part of us. If somebody is attacking us, our brain goes through a very quick activation of this system, and we determine very quickly, are we going to stay and fight, or are we going to run? And these are decisions that your brain makes very quickly. The amygdala reacts to the threat and releases epinephrine and cortisol. And epinephrine and cortisol then, in turn, increases your heart rate, increases your respiratory rate, creates muscle tension, sweating, your pupils will dilate, you get a dry mouth, and your digestion slows. So as you can see, if you think about, when you, a time when you were really upset or you were really nervous, um, there's no doubt that your heart rate increased. With that, your respiratory rate increased. Maybe you had some muscle tension. You noticed that you were gritting your teeth or clenching your fist or something like that. The sweating, our pupils tend to dilate, and we get dry mouth. And then as a kind of a byproduct of the sympathetic nervous system, when you're under all this stress, your body sees the digestion as something that's not important at that point. So your digestion slows down as well.